So now if I calculate the area of the region in the first quadrant and then multiply by 4, we will get the total area of an ellipse. Suppose if they ask you to find x square plus y square is equal to 4, then the radius is 2, because 2 square is 4, then you need to change the limits from 0 to 2. So the rest of the calculation will be same. So the area bounded by the intersection of the line y is equal to 3 and the parabola is this. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are revising the chapter Applications of Integration. So in this chapter, you will be getting one 5-mark question. So on application of integral, that is to find the area of the closed curve using the method of integration. So let's see few type of questions which we can expect for the examination. So here we have find the area of enclosed by the ellipse x square by a square plus y square by b square equals 1, and hence find the area of x square by 16 plus y square by 9 is equal to 1. So first we will find the area of the general equation of an ellipse, and then using the area formula, which is simplified by the method of integration, we can find the area of the ellipse here given x square by 16 plus y square by 9 is equal to 1. Now, roughly consider an ellipse. So, this is origin O. Let me consider this point A. So, let me consider this is the vertices A, 0 and this vertices as 0, B. Now we know that ellipse is symmetrically arranged in the coordinate axis. So that means it can easily divide into 4 quadrants clearly with the equal area. So now if I calculate the area of the region in the first quadrant and then multiply by 4, we will get the total area of an ellipse which is required for the given ellipse. So therefore here total area or required area will be 4 times integration. Limits are from distances a. So that means limit x is equal to 0 to x is equal to a. So that is 0 to a y dx. Now clearly this is given in the form of x square by a square plus y square by b square is equal to 1. So we need the value of y here. If we solve this equation, we will get y is equal to b by a root of a square minus x square. Since we are calculating the area, we will only take the positive quantity of y. So therefore, if we substitute here, this is 4, 0 to a, b by a square root of a square minus x square dx. Now b by a is a constant, we can remove outside the integral, and we can clearly see this is one of the standard form of the integral, that is root a square minus x square. So let us write the integral value for the standard integral by keeping outside the constants. So we will get 4b by a. Now evaluating the standard integral, we will get x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. Limits are given from 0 to a. Now let us apply the upper limit. So we have 4b by a by 2 root of a square minus a square plus a square by 2 sine inverse a by a. Wherever you have x, you will just substitute it as a. Now clearly if you apply 0 here, so 0, x as 0, this entire thing is 0. And if you put x as 0 here, sine inverse 0 is 0. So the lower limit value is 0 only. And you can see the first term here, a square minus a square, clearly that equals to 0. So now we have only this term. So we'll take it as 4b by a square by 2. Now a get cancels here. So it is sine inverse of 1. And sine inverse of 1 is pi by 2. 2 2s are 4, 4 get cancels, A get cancels. So the area is pi AB square units. So this is the required area of an ellipse, which we have calculated using the method of integration. Now they have asked us to find the area of x square by 16 plus y square by 9 is equal to 1. So from this expression, we can clearly see x square by 16 plus y square by 9 equals 1. Value of A is 4 because A square is 16. Value of B is 3 because B square is 9. Now since the area is equal to pi AB, so if you put A as 4, B as 3, the value is 12 pi square units. Next, find the area enclosed by the circle x square plus y square is equal to a square. Here also we'll consider a rough diagram. We know that a circle with center as an origin is divided equally in all the 4 quadrants. So here also we'll apply the same concept. We'll take A, O, B. If distance or the radius is A, then this point is A, 0 and this is 0, A. So we can take the limits from 0 to A along x-axis. So therefore here also required area can be written as 4 times 0 to A y dx. So now here using this equation, we'll get y is equal to square root of a square minus x square. Again, this is the standard integral. If we substitute here 4, 0 to a root of a square minus x square dx. So which is 4x by 2 root of a square minus x square plus a square by 2 sine inverse x by a with the limits 0 to a. We have already seen in the previous problem. So if we substitute a here, this entire thing will become 0 and the lower limit value is also 0. So here we have 4 a square by 2 sine inverse of 1. If you substitute a, it is a by a 1. So therefore, this is equal to 4 a square by 2 into pi by 2. So 4, 2 2s are 4 get cancelled. So pi a square units. We know that the area of a circle is given by pi r square, where r is the radius. Now since here I have taken a as the radius, the value should be equal to pi a square. So now I have proved the equation of an area of an ellipse as well as the equation of the circle of ellipse in general standard form. So this can also be given with the values of a and b sometimes. So previous problem, we had x square by 16 plus y square by 9 is equal to 1. So they can ask you directly to calculate the area as x square by 16 plus y square by 9 is equal to 1. So in that case, you need to change the value of a from 0 to 4 because the value of a is 4. So with the same method, you are just changing the limits 0 to a to 0 to 4. Similarly, in case of circle, suppose if they ask you to find the area of a circle as x square plus y square is equal to 16, then value of a is 4 here. So that means the radius is 4. So you need to change the limit to 0 to 4. Suppose if they ask you to find x square plus y square is equal to 4, then the radius is 2 because 2 square is 4. Then you need to change the limits from 0 to 2. So the rest of the calculation will be same. Next, find the area bounded by the curve y is equal to cos x between x is equal to 0 and x is equal to 2 pi. So let us draw the function cos x curve. So let me consider this as plus 1 and this is the minus 1 because that is the maximum and minimum value of the cos function. So 0, pi by 2, pi, 3 pi by 2 and 2 pi. We know that cos 0 is 1, 0 and pi is minus 3 pi by 2, 0 and again this is 2 pi. We need to calculate the area between 0 to 2 pi. If I draw the diagram, looks like this. So this is the region I have to calculate, the total area formed by this curve. But clearly you can see from 0 to pi by 2, the area is positive, and here the area lies in the below x-axis, which means I need to take the modulus of the area, and again the rest of the thing is above the x-axis. So I'll divide the limits here. So total area is, the first area is from 0 to pi by 2 of the function cos x with respect to dx. Next, pi by 2 to 3 pi by 2, since the curve lies below the x-axis, I'll take the modulus of the value. So pi by 2 to 3 pi by 2 cos x dx. Again plus 3 pi by 2, 2 pi. 3 pi by 2, 2 pi. So which is cos x dx. So adding all, we'll get the limits from 0 to 2 pi itself. So now integration of cos x is sine. So sin x limits 0 to pi by 2 plus sin x limits are from pi by 2 to 3 pi by 2 plus sin x limits from 3 pi by 2 2 pi. Now upper limit minus lower limit, sin pi by 2 is 1 minus sin 0 is 0 plus this is under the modulus. Sin 3 pi by 2 is minus 1 minus sin pi by 2 is minus 1 plus sin 3 pi by 2 is minus 1, sin 2 pi is 0. So this is 0 minus of minus 1, which becomes plus 1. So clearly you can see the value 1 plus minus 1 under the modulus, minus 2 will become 2 plus 1 here. So therefore the total area is 4 square units. Next question. Find the area of the region bounded by the curve y square is equal to 4x, y-axis and the line y is equal to 3. So clearly y square is equal to 4x is a right-handed parabola. And we need to find out the area with respect to y-axis and the line y is equal to 3. So consider this is line y is equal to 3. So the area bounded by the intersection of the line y is equal to 3 and the parabola is this. So now clearly here this point is 0, 0 and this point is 0, 3. So therefore the limits can take from 0 to 3. Since we are taking the area with respect to y-axis, so here the area changes to 0 to 3 x dy. X dy. Now from the equation given, y square is equal to 4x, x will be equal to y square divided by 4. So if you substitute x here, y square by 4 with respect to dy, limits is from 0 to 3. I'll keep 1 by 4 outside, and if you apply the limit for y square, then it is y cube divided by 3 with the limits 0 to 3. Now 1 by 4, so y cube by 3 means 3 cube by 3, which is 27 divided by 3 minus 0 by 3 is 0. So 3 ones are 3 nines are. So now the value is 9 by 4 square units. So these are few standard questions you can expect as an important question from this chapter. I'll meet you in the next session with new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.